The way we name type 2 compounds is to first name them as a type 1 and then add a Roman numeral. Schematically, we name it as a type 1. We check to see if it's a type 1 molecule or a type 1 metal. And if we come up with the answer no, we then check to see if it's a type 2 compound because it bears a type 2 metal. If the answer is yes, we simply take the type 1 name and add a Roman numeral. That schematic represents the rules that were previously presented in our nomenclature framework grid. And what does the Roman numeral represent? The Roman numeral represents the charge on the metal, the charge of the metal cation. With that as an overview of how and when to apply type 2 rules, let's work a few examples. Name the following compounds. The first thing we do, of course, is name it as a type 1. So this would be iron oxide. There's your two pieces. I see the two pieces. And this would also be iron oxide. Oops, the same formula cannot have the same name, but we realize what we need to do. Oh yes, this is a type 2 metal. Therefore, it needs a Roman numeral. So let's go ahead and put our parentheses to remind us we need a Roman numeral there. And now what do we have to do? We have to figure out what that Roman numeral is. So we start with FeO. We know oxygen has a 2- charge. We know from our formula the subscripts are 1 and 1. Notice here, anytime you're given a formula, you're given the subscripts. What you don't know is the charge. And we'll see later when you go from name to formula, just the opposite is true. You know the charge, but you don't know the subscripts. And how about the second compound? Well, we know we have 2 irons and we have 3 oxygens, and we know each of those has a -2. The quest then becomes, what is the charge of the metal? Because that's what is going to go in parentheses. So let's do the calculations and see what the charge on the metal needs to be to make each of those compounds charge neutral. What we know is the sum of all of the positive and negative pieces has to sum to 0. So moving to the oxygen, 1 times -2 is -2. If the total charge is -2, the total positive charge must be +2. And now moving to this, 1 times what equals 2? 1 times 2 equals 2. Therefore, this first material would be called iron 2 oxide. How about the other one? Well, we know that molecule must sum to 0, but this time the total negative charge is 3 times -2, which is -6. So the total positive charge must be +6. And 2 times what is equal to 6? The answer, of course, 3. So this material is iron 3 oxide. Now we have the proper type 2 names. Warning, this Roman numeral represents charge. It is not directly related to the subscripts. Notice that for iron 2 oxide, there is no subscript of 2. For iron 3 oxide, there is a subscript of 3. But that 3 Roman numeral does not represent the 3 on the oxygen. It represents what? The charge on the iron, the charge on the iron. This is what the search is. As a quick aside, there used to be older names where they use ic and us endings. Thank goodness they don't do that anymore. Those had to be memorized. The way to do that is merely to put the symbol for the metal, and then as we just did, to merely calculate what the charge needs to be. You don't have an excessive amount of memory required. Well, we just did some formula to name. Let's do a couple of name to formula. cobalt to bromide. Cobalt, bromide. We write the symbol for each of those. Interesting, it gives us the charge. So this time, what we don't know are the subscripts. The previous problem, we knew the subscripts. It was given in the formula. What we didn't know was the charge. So this time it's opposite. So what is the charge on a bromide? It's -1. We know that from looking at the periodic chart. What is the charge on a cobalt? It's a type 2 metal. Oh, wait a minute. It gave that to me in the name, so I know this is what? 2+. Now all I need to do is make it charge neutral. Oops, I see one of the charges is even and one of the charges is odd, so I'm just going to use cross multiply. The 1 for bromine goes underneath my cobalt. The 2 from cobalt goes underneath my bromine is the subscript. And then I clean that up and get rid of subscripts of 1 and get rid of my charges. And there is cobalt 2 bromide, COBr2. Manganese oxide, Mn is the formula for manganese. Oxide is O. The charge on oxygen is -2 because it's 2 places from being a noble gas. We can march it into the noble gas column and see we need to gain 2 electrons. Manganese, this particular manganese is +4. Why? Because it tells us which flavor it is. All we have to do is make it charge neutral. Well, I can't use my cross multiply rule because one of these is not odd or equal to 1. They're both even, so all I need to do here is add a 2 beneath the oxygen so that it becomes a charge neutral. I can see my total negative charge is -4, and that will cancel the +4. Clean that up and get rid of the charges, and manganese for oxide is MnO2. Now here's a bit of guidance you're going to want to keep in mind. When you go from formula to name, you know the subscript because the subscript is in the formula by definition. What you don't know when you go from formula to name is the charge. And that's why with the first set of questions, you had to do that around the bin thing to calculate the charge on the type 2 metal. On the other hand, when you go from name to formula, it gives you the charge. What it doesn't give you is the subscript. You don't know the formula. So, on an exam, when you're doing formula to name conversions, you need to think to yourself, do I need to calculate the charge? Because that's what I don't know. On the other hand, when you have name to formula problems, you don't know the subscript. So, depending on what type of nomenclature problem you have, that will determine what it is that you actually are searching for so that you can complete that problem successfully.